Hi everyone, my name is Thomas Kim. Today is July 23rd, 2022. This is my 30th episode for C++ 17, 20, 23, CUDA, SQL, OpenGL, OpenCL, TBB. I have created many algorithms that are missing in C++ standards. For example, I implemented TPT common type B around in 2017. In C++ 20, std common with is now introduced. If you double click it, you can find std common with. std common with is identical to my implementation TPT common type B. I also implemented TPT for workhorse, also CPT for stallion. All these algorithms are missing in C++ standard. C++ library extensions. If you click this link, you can download C++ library extensions by clicking this link. Please understand that this library is supported only on Windows operating system. By watching this video, you can learn how to install C++ library extensions on your machine. Otherwise, you may not be able to follow my current and future sessions. In this session, I will discuss one serious drawback of std forward and its solution, TPT Smart Forward. TPT Smart Forward is smarter than std forward. For some odd reason, I always make typo here. I don't know why. Without further ado, let's get started. Open up your Visual Studio Code. I will create an empty folder 030 smart forward. Click this button smart.cpp, hit enter. Ctrl V. Include talk play fun types. HPP include CPG, std extensions. From now on, I am in ESB mode. ESB stands for excruciatingly slow video mode. Namespace TPT talk play fun types. Namespace CPT CPG types. Void test. Make container. Auto A TPT make container 1 2.0 app 3.0. We can create a container like this: lcd cout type of A cpg get type category A lcd and lcd cout A std and int main, copy this function, paste it here. You can start any C++ compiler on your machine. dir cd 030 smart forward. I'll be using clang compiler std c++20 smart.cpp ltbb 12 or c.exe. It built successfully. I will copy this string and paste it here. Now we will run it. See. So 1, 2.0 f 3.0, this is double. std vector double. Common type of int float double is selected as the element type of std vector. Now auto b tpt make container. I will just copy it. Copy, paste, std tuple 3, 4, Thomas. I would copy, paste, b, 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 b. We build again. clsc. Now this is std tuple int float double, then tuple. Tuple is inside the tuple. The values are displayed correctly, properly. This is super powerful. Copy and paste. Now this is C. Here I will change 5.8 7 unsigned long. Now we can pass the container type. For example, std set. Let's try it. C, 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 C. We build again. clsc. Now the type of C is std set double. These are sorted because this is set. We can specify container type here too. So this make container is super powerful. I will explain how to implement make container. Now scroll down. Implementing tpt make container is pretty simple. Once you have tpt common type b tpt smart forward, which are missing in C++ standard library. Also note that TPT make container is extremely optimized to the level of C++ standard. I will explain how to implement smart forward. Before its implementation, we need to understand one big drawback of SED forward. So I will explain what's the problem with SED forward. Template, type name, type, void understanding, cast, type, this is forwarding reference, value, SED, cout, type, value, cpg, get type, name, type, cpg, get type, category, value, SED, NDR, void, test, cpp, type, cast, int n 5. We are calling this function by passing n, then by passing n with the typecast int. Copy this function name, copy, paste, disable it. Please understand that we are passing n integer without casting. In this case, we are passing n with casting. They are very different. N is named. N is named. So it is L value. We build again. CLSC. In this function, n is L value reference. The this type is L value reference. Value has type int, L value reference. In this case, in the second case, the type is int. Something happened. I will reopen it. Control B. The type of value is R value reference. So in this case, a copy of n is passed to understanding cast. Don't miss this point. For example, now we are passing literal 5. We build again. CLSC. So these two are identical. These two are exactly the same. These two function calls are exactly the same. By typecasting, we created a copy of n, then passed to understanding cast to this function. In such case, typecasting causes to create a new instance of n by copying. Don't forget this fact. Now I will explain what's the problem associated with std forward. I will create another function, very simple function. Show value type. We don't need type, so I'll remove this part. I fixed like this. Like this. Here, template, type name, int, type name, dbl, void correct, common forwarding, int, forwarding reference, n, dbl, forwarding reference, d. Here, std, cout, type of n, cpg, get type, category. We pass n, std, and there. Copy, paste. The type of d, we create a common type using common t, std, common type t, int, dbl. So we are taking common type of int and dbl like this. Now std, cout, common t, cpg, get type, name, common t, std, and l, std, and l. Now we forward n and d as common type. We forward n and d with common type casting. std, cout, n, show value type. We are calling this function. We forward std, forward int, n, copy, paste. D, DBL, D. Common type of int and double is double. So we pass common T. We give typecast to int. In case of double, we don't need typecast. This is correct forwarding for common type. SED, cout. Correct, but impractical. Common forwarding. SED, and there. I will explain why this is impractical. SED, cout, SED, and there. I will remove blank space. Then void test forwarding common types. Copy this function, paste it here. Now disable it. Scroll up here. Int n 1 double d 1.1. We call this function by passing n d. Now we rebuild CLSC. So correct but impractical common forwarding. In this function, we forwarded n and d to show value types. In show value types, the value of n 1 because we set n 1. The value of d is 1.1. The type of d, this is L-value reference. D is forwarded properly as L-value reference. In case of n, a new copy of n is created, then converted to double. Because we are forwarding common type of int and double from this function, we are forwarding n and d as common type. Common type is double. In case of int, we have to do typecasting. So this typecasting creates a new instance, double. This is correct behavior. Now copy this, paste. This is failed common forwarding. I say failed common forwarding. Now scroll up. In this function, correct common forwarding, how can you know the common type of int and double is double? if we do typecasting here, something weird happens. Now scroll down. We cannot know which one has the common type, so we have to typecast to both sides. Now we call this failed common forwarding here. Copy, paste, failed common forwarding. We build again. CLSC. This is correct, but impractical. This is correct forwarding. Correct common type forwarding. In this case, failed common forwarding, a copy of double, a copy of D, a copy of N, a copy of N is created. So two unnecessary copies are created. So this is not very useful for optimization purpose. This is failed. We cannot use std forwarder like this when we try to pass common types. Instead of doing this, copy this, paste it here. I would change smart common forwarding. Smart common forwarding. Now we don't use std forward. Instead, tpt smart forward. We pass both common type and int. tpt smart forward common t double. We use smart forward in this case. Now copy this, paste smart common forwarding. We rebuild. CLSC. Now let's check. Correct but impractical common forwarding. This is the correct result we want. Failed common forwarding. It failed. D, a copy of D is created. Also, a copy of N is created. In this case, D is forwarded as L-value reference. Now, smart common forwarding. D is passed as L-value reference. N is created and converted to double. This result exactly matches. This has very important consequence for optimization. When we have to forward common type, we can use smart forward